This video aims to provide you with an introduction to periodic trends, as well as a general introduction to the periodic table itself. So over here on the right is an image of the periodic table, which I took from Wikipedia. And as you can see, there are different groups going up to 18, and periods down to 7. And I'll define what a grouping period is in a second. But what's important to note is that the periodic table is a way that we organize the elements in order to illuminate and highlight certain trends that we see. So first off, you may be wondering, what is an element? We have all these elements here, but what really are they? Well, all an element really is is a substance which only consists of one of atoms which have the same number of protons. So it's a substance only consisting of atoms that have an equal number of protons. So for example, an element of hydrogen, every single atom in that element would have only one proton. For boron, every single atom in that element would only have 5 protons. If we take praseodymium, every single atom of praseodymium will only have 91 protons, no more and no less. So that's all an element is. Another important definition is atomic number, which is the number of protons that are present in an atom's nucleus. So, for example, an atom of hydrogen would have only 1 proton, and therefore would have an atomic number of 1. Boron would have an atomic number of 5. Praseodymium would have an atomic number of 91. Since all the atoms in praseodymium have only 91 protons. It's also useful to define the term period, which is simply a row of chemical elements on the periodic table. It's also useful to define the term group, which is simply a vertical column of chemical elements on the periodic table. So this would be the first period, second period, third period, fourth period, so on. First group, second group, third group, fourth group, 18th group. So now with some definitions out of the way, let's look at some trends. So over here I have a metal, or more specifically iron. And here I have carbon in the form of coal and graphite. Generally on the periodic table, as you go more towards the left, so like iron over here, or even lithium, beryllium, you get metals. And as you go further to the right, you get nonmetals like carbon, boron, nitrogen, oxygen, fluorine, and neon. And metals are typically substances that have a high luster, so they're shiny, and conduct both heat and electricity quite well. So an example of this would be iron. Contrast. Non-metals are essentially the opposite of metals. So they just have the opposite characteristics. They are substances which have low luster, so they're essentially just not shiny. And they're not very good at conducting heat and electricity. So nonmetals are substances that have low luster, not shiny, and do not conduct heat or electricity well, or sometimes not at all. Over here, I have examples of carbon, just in two different forms. Carbon in your pencil, known as graphite. It is common to call the thing at the end of your pencil lead, but it's in fact carbon. And then over here we have coal. So now let's go back to trends. Elements and groups tend to have similar properties. So for example, lithium, sodium, potassium, rubidium, cesium, francium, they all have similar properties. Same with the elements here, like helium, neon, argon, krypton, xenon, radon, and oganesson. Elements and groups have similar properties. So let's write that down. Elements and groups have similar properties. That's an important point to remember. In group 1, we have the alkali metals. And these metals are generally these metals generally react with water. These metals generally react with water, can form salts. They have generally, and they generally conduct heat and electricity well. So all the metals in group 1 have these properties. Now what's interesting is as you go down the group, so lithium, sodium, potassium, rubidium, cesium, francium, they become more reactive. So they become more reactive as you go down the group. In group 2, then you have your alkaline earth metals. And they're quite similar to the first group. They are, after all, close to each other on the periodic table in terms of period. However, they're usually slightly less reactive. They can also form salts. And similarly, they become more reactive as you go down the group. So you'd expect barium 56, or not barium 56, but just barium in general, to be more reactive than beryllium. It's also important to discuss group 17, which are the halogens. And the halogens are also quite reactive. Similar to the alkali earth metals, which I should write, in fact. Very reactive. They're able to react with alkalis, alkali metals, very easily. And also they react with the alkaline earths and just in general with metals to produce salts. And what's interesting about the halogens is that they get more reactive as you go up the group. So as you go up from iodine to bromine to chlorine to fluorine, they become more reactive. This is the opposite trend. And then the final group which I'll discuss is group 18, which are the noble gases. And in contrast, the noble gases are very unreactive. In fact, when they were first discovered, people believed they were inert and that they couldn't react with anything at all. They were later renamed to noble gases. However, since it's not that they don't react with other elements to form compounds, but it's just difficult for them to react, or that a lot of them are unreactive, or have difficulty reacting, or only react under very special conditions. As such, because they're not very chemically active usually, they're colorless. They are also odorless, so you can't see them, you can't smell them, and you can't taste them. And it's difficult to make them react with other elements. However, it is not impossible, and they do get slightly more reactive, or actually quite more reactive, as you go down the group. So if you have something like xenon or radon, you could expect to make a few compounds with these noble gases. However, if you're talking about something like argon, neon, it's much more difficult to do so, and it is extremely difficult to make helium form a compound with anything whatsoever. It's very difficult. And those are the basic trends of the periodic table. And yeah, I hope you enjoyed the video. I hope you found it useful, and thank you so much for watching.